A library checks out an average of 325 books per day with a standard deviation of 61 books. The number of books checked out follows an unknown distribution. Consider a random sample of 111 days of operation. Let capital X bar represent the average number of books checked out per day over a selection of 111 days. And then we need to define the distribution. So that little tilde means how is it distributed and what are the parameters. So we're going to have to use the central limit theorem here because we're being told about an average number of books per day with a standard deviation that's given. But then we want to know the average over several days. So it's like we want the average of the averages. So the original population would be the average on a day, 325 books with a standard deviation of 61. So that's our original population. Now, if we take a sample of 111 days and take the average of all those averages, that would be our random variable here. And so we'll need to use the central limit theorem to see what the distribution should be. The central limit theorem says that the sample mean of, or the mean of means, the sampling distribution of sample means will be normally distributed if one of the two are true. Either you have the individual values or the original population is normally distributed, or the sample size is greater than 30. Now, if you can say yes to one of those, then you'll know how to define the random variable or the distribution of the random variable. It will be normal with the same mean, but the standard deviation will have to be divided by the square root of the sample size. So we read that the number of books checked out follows an unknown distribution. So that's a fail on the first possible qualification for using the central limit theorem. We don't have knowledge that the original population is normally distributed. So moving on to the next qualification, is our sample size greater than 30? Yes, it's 111 days. So that means we can still use the central limit theorem even though the original population is not normal. And we know that the sample means will not, I didn't mean to say also, it will be normally distributed even though the original population isn't, or at least it's unknown whether it is or it isn't. So we have a normal population. We're going to have the same average as the original population, 325 is the mean, and the standard deviation is 61 divided by the square root of the sample size. So 61 is the original standard deviation divided by the square root of 111.